Hello everyone, welcome to Bratati's science class. I am Bratati and today I am back with the fresh chapter of class 9, chapter number 11, and the topic is, what is the topic? What it is? This is sound. Yes. So today we are going to the topic sound. So without wasting the time, let's begin. I will share my slides with you, and even time permits, if the time permits, we'll go through the chapter exercise. So before starting, I am sharing with you, yeah, that those who have not gone through it, please go through the channel playlist where you can see class 9, class 9, class 8 and class 7 science, all the chapters. Okay, so if it is not done, please go through it. And okay, so this covers what is sound, what is wave, the characteristics of sound, the characteristics of wave, the sound range. That is what as a human we can hear. All right, so let's begin. Sound. So when the word comes sound, it's a form of energy. So in previous chapters we have gone through, there are different forms of energy. Energy can neither be created nor be destroyed. It just transforms from one form to another, which is called the conservation of energy. Right? So sound is also a form of energy which is produced by a vibrating object. So it is produced by a vibrating object. Like when we are clapping, these two hands are, this place are vibrating. When we are speaking, here our vocal cord is vibrating. We call this larynx. It's a larynx or a vocal box which is continuously vibrating to produce the sound. So it can be, number one example, the sound from our voice where it generates from larynx. Larynx is nothing but vocal box. Okay, so for sound we have to keep it in mind that it travels through a medium. That medium can be solid, liquid or gaseous medium, and also it travels in the form of wave. All right, so when any particles, so as we know that molecules, atoms, there are small particles everywhere and the matter is made up of the particles. So when we are vibrating, we know our hand is also made up of the particles and these particles are vibrating. So basically particles are stable in normal condition when they have sufficient energy. So when we are full, we have taken our food sufficiently, we are full, we don't want to eat more. And when somebody is trying to push us, or if we get a delicious biryani or our favorite food, then we have a tendency of eating more. And once we eat more, we get unstable. We feel like we have to do exercise to feel comfortable. So we do exercise, we walk for some time to feel comfortable. That means we have to adjust that excess food intake. Similarly, a particle becomes unstable when excess energy is pushed to it. Okay, I am now stable. If somebody push me, I will move this side. Or from his side, if somebody push, I will go that side. So this is my unstable condition because I'm getting the push from either side. And this is my stable condition. So here, when there is a single push, this single push is causing the disturbance. This particle will go and push to the next one and so on. So this single push is called pulse, P-U-L-S-E. Okay, the particles become unstable when they get this pulse. Pulse is the single disturbance. But when multiple disturbance is there, we call it as wave. That is continuous disturbance in a medium. We call it as wave. That means here how this wave is formed. This wave means this particle, they are continuously moving. either this side or this side. Okay, if the particle is here, either it's moving up and down or the particle is moving left and right. So either up and down movement or left and right movement. So if it is up and down, the wave is like this. If it is left and right, then the wave is like this. Okay, so up and down or left and right, both cases, the wave is formed. And in this wave, the mode of transmission of energy requires some medium where particles are not moving. Just see properly, the particles, this is their mean position. From the mean position, they are moving either to and fro or back and forth. They are not getting displaced. So without the movement of the particles is important here. Particles are not moving. Only the transmission of the energy is moving. So this is the movement of the energy, but not of the particles. What is vibration? The vibration is just now, as I said, either to and fro movement or the back and forth movement of the particles, that we call it as a vibration. Okay, now coming to the types of waves. The waves are of two types, the electromagnetic wave and the mechanical wave. The electromagnetic wave like UV rays, okay, ultra violet, UV rays, or this require no medium at all. Okay, electromagnetic wave needs no medium at all. They even work in the vacuum, but mechanical waves, they need a solid liquid or gaseous medium to move, and they cannot work in vacuum. So coming in details of mechanical wave, again this can be of two types, that is transverse wave and longitudinal waves. So as the movement of the particles go up and down, this is the up and down movement of the particles, and the wave is moving from horizontal way, right? So this up and down movement, this is the movement of the particles and this is the movement of the wave. So this is basically creating a perpendicular relationship. So the particles are oscillating in perpendicular to the wave motion. And in case of longitudinal wave, the particles are moving horizontally left to right, and the wave is also moving horizontally. So basically they are parallel to each other. So one is, that is the longitudinal waves moves parallel to the particles oscillates to parallel to the wave motion like sound wave, and transverse wave, there the particles are oscillating up and down, which is perpendicular to the wave motion, that is transverse. Now how do the sound moves? As I said, the particles are not displacing from their mean position, only the energy is transmitting. So this is the source of sound. This is the source. It can be a mic or it can be any other thing. So this is the source of sound. Here we can see when the particles, so it is like a push. So when the sound is coming near, it is moving in the air, right? When we are able to, you are speaking, I am able to hear. When I am speaking, you are able to hear. The medium is air here, gaseous medium. In the gaseous medium, the gaseous particles are there. So where we are speaking, there will be the rarefaction and it is going and pushing to the next particles, which is again close to the another particle. There it's a compression where more particles are there. This place, more particles are there. This is the compressed area. Again, after that, they are going, they are separating and they are pushing to the next particles. So there again, the rarefaction. So it's a RC, rarefaction, compression, vice versa. It's going like this. The sounds moves in the form of rarefaction, which we denoted by R here, and the compression, which we denoted by C. Now see, in the compression area, the particles density is more. If the density is more, so the pressure is also high in the compressed area. Where the particles are compressed, the density is high, so as the pressure is also high. But in the rarefaction areas, there both the density and the pressure, both are low in the rarefaction areas. Now see, This is the average density. This one, this mean graph, it is the average density. So the density, I mean, when the particles are moving up and down, okay, then maximum, this is the amplitude. We will learn about this amplitude. Amplitude is when the sound is the maximum displacement from this average density towards up or towards down. That is called amplitude. So the maximum positions where this wave can go, that is the high density region, and the lowest when it's coming down, this is the low density region, low density particles. And this top part, we call them as crest, C-R-E-S-T. And this lower part, we call them trough, T-R-O-U-G-H. Between two crests, the distance between the two crests or the distance between the two troughs, we call them as wavelength. This wavelength is measured as the Greek letter lambda. We call it L-A-M-B-D-A. It is lambda. Okay, so now see, in the transverse wave, the particles oscillate perpendicular to the wave. This is the perpendicular to the wave, where there are these two crests and the troughs are present. Now, where can we see this? When in a clean and calm, quiet water bodies, you throw a stone. There we create a disturbance in the water, isn't it? And there we see the water particles are moving up, down, and that is transverse wave, where we see up, that is crest, and trough, that is down. So the hills area, this hill area are called the crest, and the valleys are called the trough. Okay. Now, in case of the longitudinal wave, the particles oscillate in parallel to the wave, where we have CR, that is, it is compression, rarefaction, and again compression, rarefaction, and so on. And that example is the sound wave. When we are speaking, the sound is generating, right? So even here I was showing you, in this guitar or any musical instrument, there are the strings. These strings these strings are vibrating, and that is creating a sound. Now, in the characteristics of wave, what some definitions are there, also the formula which are required for your sum. Now, you may ask me why I'm going so fast. Children, you already know the concepts. This class, Bratati Science class, is for your revision of the topic, where we are discussing the textbook exercise. The problems are also being solved. But the main thing is, it's a quick revision. If any doubt is still there, you can clear it if you listen, if you observe, or if you follow the channel and if you follow the classes. So there we get the definition of frequency. The frequency is number of oscillation per second. Remember, which is, so number of oscillation in the sense, if this is the average density and it is one oscillation. Okay, number of oscillation is from the crust to another crust. It's going like this. So one crust to one crust, this distance we call it as a lambda. And the frequency is for a complete oscillation. So from this place to this place. This one is a frequency, and the time period T is the time taken for one complete oscillation. How many oscillations? So for here, this is 1, this is 2, from here to here it's 2, again from here to here is 3. So we can see there is 3 oscillation per second, 3 oscillation per second. So 3 hertz will be the frequency. For example, frequency will be 3 hertz. And to receive this frequency, the time taken, if it is 3 seconds, then that will be the time period. There is a relation between the frequency and time period. The frequency is 1 upon time period. Okay, so frequency is always 1 upon time period, and these equations we know from beforehand, that speed equals to distance upon time. So in that case, so we get, if we compare this to, from there we get V, that is the velocity. This is lambda, that is the wavelength into the frequency. And if you know velocity, of any particle. If you know the wavelength, you can quickly take it out, what will be the frequency. And if you know the other two things, that is the wavelength and frequency, you can take out the velocity of any particle. So after that, we are going to characteristics of sound, where we have to know what is the amplitude. As I was telling you, remember, amplitude is how loud is the sound. Ah, okay. Ah. So that means the loudness of the sound, the magnitude of the maximum disturbance in the medium, in either side, either up or down, of the mean value. So the middle one is the mean value. And this is the maximum disturbance either side, whether it's up or down, that is the loudness. So the more the magnitude, the amplitude is more, right? Amplitude is more. And this is amplitude is less. This is less amplitude. Amplitude is less. That is less loud. And this is noisy. Noisy means more amplitude. Okay, so one is noisy. Noisy is more amplitude, and less loud or less noisy. That is, if a car is honking, what we call the amplitude is more, so it is noisy. So the amplitude is more in honking car rather than the shrill sound of the cuckoo bird. Okay, now what is pitch then? The pitch is how our brain is interpreting the frequency of the sound produced. So you know, we cannot persist. I mean, there is a point 0.1 second time. In this time, our brain cannot interpret a different sound as a different one. They consider it's a same sound. So to make a distinct sound, we need to create another sound at least after 0.1 second. So how our brain interpret the frequency of an emitted sound is the shrillness of the sound or pitch. So when I speak, it is my normal pitch or normal voice. When I speak, it is science class. Please do subscribe the channel. So I'm using a high pitch, or it's like a shrill voice. Okay, how brain is interpreting. Or if I say, hello everyone, welcome to Bratati science class. And if you have not subscribed, please do subscribe the channel. So this is the high, and it is kind of low pitch voice that we see for the male. Okay, the boys, the male, their voice low pitch, that is not shrill. So as you can see, this is almost flat compared to this is which is going up and down movement. So this is the difference between the low pitch or male voice and the high pitch or the female voice. Then what is timbre? Timbre is an interesting quality of sound by which we can differentiate between each individual. Even in a crowd, we can identify them because for each person, for each animal, the timbre is different. That is the quality of sound where even we can differentiate the sound with same pitch and same loudness. Whether the amplitude or the pitch is same, but still we can differentiate a sound or a voice of a person by using the timbre. Now, what is tone? When we speak, it's so boring. What he's saying, it's a monotone. Monotone means single tone. When there is a mixture of tone, we call it as a note. So when we sing a song, we generally say, where is your note of this music? Okay, of this song. The note of the song is the mixture of tones. Now, speed of sound, it is important. The speed of sound is different in different media. It depends on the media. Yes. So, the speed of sound is obviously less than the speed of light. It takes only 8 minutes to reach the sunlight to Earth. And what we call the speed of light is 3 into 10 to the power 8 meter per second. But at 22 degrees centigrade, that is normal temperature, the speed of sound is 344 meter per second, much less, quite less. And that is the reason we see the flash of thunder first, and after some time we can hear the sound, isn't it? So when we see the flash of thunder, we become alert. Now we are going to hear the sound. Put your hands on your ears and get ready for the sound. Countdown start. 1, 2, 3. Boom. So this is what happens because of the speed of the sound is also depend on different media. In solid media, the speed is maximum, then in liquid, and last in gas. When we increase the temperature, the speed of the sound also become faster. So in 0 degree centigrade in polar region, the sound won't travel much compared to the hot area or equator region. Clear? Okay. So reflection of sound, it's like the reflection of light only. So the sound goes and get an obstacle, whether it's a solid or liquid, and bounces back. This is called reflection, which follows the laws of reflection, that is the incident, reflected, and the normal. These three lies in the same plane. The incident angle and the reflected angle are same, that is theta 1 equals to theta 2. This is the normal. Consider this is the incident sound and this is the reflected back sound. When somebody is standing here and here is the heel, okay, this person is having a gun, shoot here, this is distance d, and it comes back to us that the sound travels 2D actually, right? So this sound, I mean, getting reflected, this angle will be same. They are all in the same plane. So what is the condition? The conditions to hear the reflected sound clearly. I repeat, clearly. To hear the reflected sound clearly, there must be minimum distance between the source and the obstacle is 7.2 meter. Now, why this? As I was telling you, s is the speed of sound is distance by time. Here the distance is 2d and the sound say zero point 0.1, because without 0.1, as I said, we cannot hear a distinct sound. Now, s is 344 meter per second in 22 degree or normal condition. Then d equals to coming as 17.2 meter. This 17.2 meter is the minimum distance, or it can be more. Next, persistence of sound of brain. I mean, the brain cannot interpret. So the time must be more than 0.1. So that's why we took it as a minimum distance, because it is a minimum time. And speed of sound in air is 344 meter per second. Then if we know about reflection, then what is reverberation? Reverberation is multiple reflection which causes the persistence of the sound. The source of the sound is same. But here, you know, if it is a curved surface, here is the movie theater. In the movie theater, this is the screen. From here, the sound, here, or the audience is sitting or standing. So from here to here, from here to here, and from here. Again, one will go this side, then again it go this side, and come here. So the sound is reflecting more than one times, and that persistence of sound, which is called as reverberation. Okay, so these reverberations can be used in, you know, if there is a sheep, if there is a sheep, and okay, this is the you know, there it is in the ocean and there is some iceberg or some hills. What happens, they have a transmitter and they have a detector. So this one is a transmitter, this is the transmitter, and this is the detector. Okay, so what happens in transmitter, this is the ocean bed. So this, they take this distance, okay? They take this distance and this, they get the detector. So this is the transmitter. The sound comes down and get the reflection back to the detector. So they just determine the time taken and the distance. If it is d, the distance is d. So from this they can take it out. The velocity of the sound is known here. So we know the velocity equals to 2d by time. So with this we can get to know the distance. Okay, the d can be calculated. So if you know the velocity, if you know the time taken, the d is, we can find out the d. And if they find out the d, then we will come to know that how what is the distance or how much depth it is from the ocean bed. Accordingly, the sailors will be taking the precaution. Okay, so now in the use of the reverberations, where can it be used? Many musical instruments like Shehnai, and trumpets. Okay, there we use the reverberation. Even the doctors, they use the stethoscope to get the clear sound of the heartbeat, where they focus on a particular channel. And the movie hall, they have the carved ceiling. Okay. Next, sonar system. This sonar system is also a use of this reverberation, where we use the ultrasonic sound for sound navigation and also the ranging. So the range of the, or the height of the heels and all that can be measured. Even sonar system, and many a times many organs where we have to check it with the sound only. The sound, we can see the difficulties in any of the organs where it's we cannot see them. So on those places we can put the sound, and with the sound we can get an idea there is obstacle or not. Now coming to the range of hearing, for human ears, it can range, the range is 20 hertz to 20 kilohertz. The sound which is, the frequency is less than 20 hertz, okay, like the mosquito is moving, or even the hummingbirds can flap their wings, in 60 seconds per second, how many times? 60,000 times or so. So we cannot hear those sound because those frequency are less than 20 hertz. And if it is more than 20 kilohertz, okay, those are the ultrasonic sounds. Even that is beyond our capability. But you must have seen, those who have pets at home, the animals like dogs or cats, they can understand and they can realize those kind of sounds. Okay, and then their ears will be alert, they will be alert, and they will start barking. So human range is 20 hertz to 20 kilohertz. Within that certain frequency only the human ear can hear. All right, so what is the application of this ultrasound? As I was telling you, the sound that is below 20 hertz, it's called the infrasound. It is called the infrasound. And the sound which is above 20 kilohertz, we call them ultrasound. And the use of the ultrasound is the medical purpose, mostly the industrial purpose, and even to clean different parts of electronic components, small parts, music systems, audio systems, where with the sound we can clean those parts where we cannot reach physically. With the heavy vibration, those parts will get clean. So with this, for this vibrations, we put the solution to clean it. The solutions will clean this with the tremendous vibrations, and then that our work will be, our purpose will be solved. Even it helps to detect the cracks and the flaws of building during this construction process. You might have seen that they are generating that peculiar sound, and with the sound they are checking that whether there is any crack. After complete building, if we measure, if we find out the faulties or the cracks, it's not going to help. It's better to beforehand we need to check if any fault is there, we have to rectify, then we have to proceed. Echocardiography, that is the heart surgeons, heart doctors, okay, they always suggest for angiogram, echocardiogram, to get a proper idea and to get confirm that if you have a blockage or any surgery is required or not. Okay, so hope you understood. We are almost done now. Coming to this exercise and few of the solves, I will come to our textbook, NCERT books, where I will show you few sums. That is, the first sum will be these questions, I think page number 132. Guitar or car horn, which of this sound has a higher pitch? Obviously, it's a car horn, which is very noisy, not the guitar sound, which is very soothing to our ears. So the higher pitch is the car horn. The higher pitch, the more shrill sound. So we are on page number 132, where question number 2 is car horn has more pitch, high pitch rather. Okay, the speed of the sound, speed is V equals to distance by time. A sound wave, example 11.1. Okay, 11.1 we are. A sound wave has a frequency of 2 kilohertz. That is nu equals to 2 kilohertz. Wavelength lambda equals to 35 centimeter. What we can convert to meter? That will be 0.35 meter lambda. Now, how long will it take to travel 1.5 kilometer? So that means the distance D here equals to 1.5 kilometer, which we have to convert to meter by multiplying with 1000. They are asking about the time. The time is D by V. And this V equals to lambda V. So lambda is given, V is given. So let us put here D equals to 1.5 into 1000 to make it meter. Okay, lambda is 0.35 meter into the V is 2 kilohertz. Right? 2 kilohertz. 2 kilohertz is again 2000 hertz. So now see this will go, and so if this goes it will be 150. So it is 15 by 7, or we can call it as 2.1 second. You have calculator to calculate, but the simplification what I have shown, if you want to remove this, there will be 1 0 added here. Okay, this will be removed. So here 150 by 700, 150, and this is 70. So 150 by 70 equals to 115 by 7. Got it? Here 1 0 will be added. Now see, it is 15 by 7. Now, so as I said, speed of the sound in different media, you remember in solids, the speed is the maximum, and in the gases, the speed is the minimum. Then we go to reverberation. Reverberation 11.2. That is, let's go to the next page. Here, page number 134, and we are into 11.2. Here it is saying a person clapped his hands near a cliff and heard the echo after 2 seconds. So what is the distance from the cliff to the person if the speed of sound is 346 meter per second? So here the speed of sound is 346 meter per second, and time taken t is equal to 2 seconds. Then the distance equals to v into t. So here v is given 346 into 2. That is, if we just omit the units, we got it 692. It is meter, because it is the first one was meter per second. So meter into second by second. So this second will cross 692 meter. In 2 seconds, it has to travel twice. Now this is the 2D. So therefore 2D equals to 692 meter. Therefore D will be 692 by 2. That is 346 meter. Is it clear? So a person is standing here. The cliff is here. So from here to here, it's D and this D. So this 2D will be considered as 692. So with this, I hope it is clear today. I'm not exceeding today much. So as you support, thank you so much for your support. And definitely I will proceed to the exercises, the question answers, and any doubt is there, please share with me in the comment box so that I can be more available to you. And even you need, you can ask for a tuition as well, because we do that. I mean, I take the science classes on one-to-one basis. That also you can message me, I mean, in the comment box, so that I can put you in the message. And if you like any part of the video and if it is easy to understand, then please click the like button. And if you have not subscribed yet, request you to do the subscription so that it motivates me to do better for you, to bring more new topic for you. One more lesson and then we are moving to class 10. So hopefully we can cover till graduation. So that is the aim of Bratati science class. So thank you for all your support. Stay healthy, stay good, stay happy. Happy learning and keep learning. Tata.